So the first part of this lab continues on topocentric coordinate. They are the first 3 pages of this lab where you will read this topocentric coordinate map of stars. So remember from the previous lab or from the review videos, the topocentric coordinate are local coordinate to the observer. They depend on where you are on Earth, which day, and at which time you are observing the sky. So as the star move through the night sky over the course of a night, because Earth is rotating, those topocentric coordinate system constantly change. So on this map, you have written down the azimuth and altitude of each star. The outer circle is representing your horizon. So if we talk about the altitude, it starts at 0 at the horizon up to 90 degrees at the center of the map, which represents your zenith. So really make the correlation between the middle of the map is what you will see directly overhead, and as you go toward the side of the map, you're looking closer and closer from the horizon. And so you can read the label. It starts at 0. Then this will be 20, then you'll have 30, 40, 50, 60, 70, 80, and 90 degrees of altitude. The other set of coordinates is the azimuth, your direction. So direction is a full circle, so it goes from 0 to 360 degrees. North is by convention set at 0 or 360 degrees. South is 180. So how do you read coordinate of stars? So if we take, for example, Alphard, here you would read the azimuth. It is close to 140 degree of azimuth, but it's a little bit past 140 on its way to 150. So the middle would be 155. So Alphard, you could set it to 141 degree of azimuth. South is here, east is here, which also 141 would correspond to southeast. That's your azimuth. Now for the altitude, you want to know how high Alphard is from the horizon. Remember, this is 0. The first line will be 10. This line is 20, 30, 40. Alphard is very close to 40 degree. You could make that a 39. So that would be 39 degree of altitude. Alphard coordinate are 39 degree of altitude and 141 degree of azimuth. That's how you read such a map. And those coordinates are valid for a specific location and a specific time. So in this lab, you will have to complete the 3 tables reading the map. I will give you some altitude and azimuth coordinates. Find to which star it is corresponding in the map. For example, let's take the first example. Altitude 69, azimuth 309. So altitude 69, we're looking at something around that circle. Azimuth 309, so 200, 320, 310, around 69, that's Menkalinen, the star. So you would just put Menkalinen here. Then the opposite exercise on this table, this time I give you the name of the star. Try to find the coordinate in altitude and azimuth. So for the star Alnat, you will see there is some star that the name can be quite difficult to read. There is also planet, there is Saturn, there is Venus, 2 planets in there. And let me see if I can. Alnat is this star. This is an N. So that's the last star on the second table, Alnat. And on this one, then we work on the last table on the concept of transit. So transit is also your meridian. When your star is transiting, it is found on the meridian, it is found on the north-south line. So imagine as you're standing outside, you look right above your head. This is what you find in the middle of the map. Then you face north. As you go up the map, you're going toward the south. So if you're facing north, this part of the map is in your back. You're going from looking in front of you to looking above your head to looking behind you toward the south. So now when a star is before transit, all objects in the night sky rise on the east, set on the west. So a star before transit, before going to the meridian, will be rising, going to the meridian. It would be fine in the right part of the chart. A star after transit will be on its way towards setting after it passed the meridian. So it will be on the left part of the chart. That's your second column there. If you ought to know if you will find it more north or south, where the bottom part of the chart is north, the top one is south. So you just, in this map, you have to tell me in which one of those 4 corners your star is in the chart. And so remember, everything rises on the east and sets in the west. The first part is some type of homework. Is just recalling your definition from your lecture. So if you haven't looked back to your textbook to find the definition of what the ground level is, how you call this point directly overhead, and to which altitude does it correspond. This one is to make sure you understand how the circle works. So by convention, north is 0, south is 180. It goes from 0 to 360. So give your answer for how approximately how many degrees apart from north A is. Same thing for B, C, and D, east and west. And you have several questions to answer. Don't forget those 2 on the side too, regarding altitude, azimuth, and the North Star. So that's for the first part of the chart. On this lab, I have a bonus question. And this bonus question, you'll be able to complete it most likely after you do the Planis report, the second part of the lab. So this topocentric map is local. It corresponds to a particular location on Earth and also to a particular date and time. So using your knowledge from astronomy lecture, from some part of the lab that we're doing here, from the previous lab, you will get bonus point if you can find the location on Earth. For this, just give me the latitude. Which latitude are we? And so which big city is found on this latitude? So find the latitude and the big city. That will be 1 bonus point. And then let me know which date and time this map corresponds to. There is few options there for the date and time. But so let me know. So there's 2 other bonus points for the date and the time, plus 1 other bonus point for location of latitude and nearest big city.